Today, I want us to talk about Euclidean geometry. This topic is quite valuable to all of those of you who will be doing grade 11 and metric this year. So, the topic itself is quite easy if you can be able to do it bit by bit and not dive in head on, because if you dive in head on, it might seem quite difficult. So, I will be breaking it part by part and creating a playlist for you here on YouTube so that you are able to access it and be able to gain access to different kind of chunks on this topic. So, in this first video, I want us to talk about three things, just three things. I want us to talk about lines, triangles, and circles. Just three simple things to start off. Okay, so let's talk about lines first. Let's forget about the others. Let's talk about lines. So, you first need to understand what a line is. A line is a structure that looks something like this. A connection, a line is simply just a connection from one point to another point. So you're connecting points to form a line. So there are different types of lines, and these lines are very important because they're going to be used to form the shapes that we're going to be talking about in this topic. So we have different types of lines, and the first lines that I want to talk about are parallel lines. So these are lines that look something like this. So these are parallel lines. Please forgive my drawing. Something like this. So these are parallel lines. These are lines that are going in the same direction at the same time. Parallel lines are not the same as equal lines, which we're going to talk about. Parallel lines are going in the same direction at the same time. This is where you would hear your professor talk about something like fun. Fun. What does this mean? So it talks about the F refers to corresponding angles, then co-interior angles, and alternating angles. We will talk about this in depth as we go on with the video. So firstly, let's talk about the different types of lines. Let's just forget this for a moment. So we have parallel lines, which we have just spoken about. So if you see something like this on an exam sheet, just know it's a parallel line. These are parallel lines. These are parallel lines. So these are lines that are going in the same direction at the same time. Okay, so let's speak about other lines now. So the other types of lines that we can speak about, these are equal lines, often denoted by this type of a figure right here. These lines here in the center show that these lines are these lines. It shows that they are equal. Equal means they have the same length. Yeah, that's pretty much the gist of it. They have the same length and they're going in the same direction. So these lines have the same length, therefore they're equal. So that's what we have. When you see lines like this means that you have equal lines, just like that. So to recap, when you see lines that are like something that look something like this, these lines will be much straighter than I have drew them. This suggests that these lines are equal. So we're talking about equal lines. Equal lines. right? Okay, so those are equal lines. So now I want us to move on to the shapes that these lines form. One of the shapes that lines form are triangles. So I want us to talk about that for a little bit before coming back to lines. So we have triangles. So what are triangles? Triangles are when three lines are joined together to form a shape with three sides. So this is the kind of shape that I'm talking about. So if you see a shape like this, we would now be talking about a triangle. A triangle. And there are different types of triangles, as I want to talk about the different types of triangles that are there. So in this topic, we're just addressing the different things that are available, that are there in these mini chapters, from lines to triangles to circles. So what are the different types of triangles that are there? Let me talk about that right now. So firstly, I want to talk about an equilateral triangle. So pardon my drawing, but an equilateral triangle is a triangle where all the sides are equal, meaning this side is equal to this side, is equal to that side. So let's just say we were labeling the side A, we label the side B, we label the side C. That means AB is equal to BC, which is equal to AC. All these sides are equal. AB is equal to BC, which is equal to AC. All the sides are equal. So when you have a situation like this, we call this an equilateral triangle. An equilateral triangle. So another type of triangle that we have is a right angle triangle. A right angle triangle looks something like this. So you would have a 90-degree connection here, and then you would have a long line joining these two lines at the bottom over here. A long line joining these two lines. So depending on where the angle is, the opposite and the adjacent can be interchanged. For example, if the main angle is over here, then this is the opposite side. And this would be the side that is adjacent. So that depends on where the main angle is. That's how we decide which one is the opposite and which one is the adjacent. If the main angle is here, then this side would be the opposite, and this side would be the side that is adjacent. And then the hypotenuse or the hypotenuse, I don't know how you guys pronounce it, which is this one here, which is the hypotenuse. It's the side opposite the 90-degree angle, so it never changes. It's just the side opposite the 90-degree angle. The opposite and adjacent can change depending on where the reference angle is. So that's what I wanted to talk about there. And then also, I want to talk about another type of triangle that we have, which is a triangle where all the sides are not the same. So it's a triangle in which all the sides are not the same. They're all different. They're all just different sides. So this type of triangle here, you can see that none of the sides are equal. So all the sides are different. Therefore, all the angles are different. So this type of triangle here is what we call an isosceles triangle. Pardon my spelling. Isosceles triangle. So this type of triangle is a triangle where all the sides are different. You have different sides throughout. Okay. Okay. So now I want to just take a detour and get back to lines for a little bit. So let's get back to lines just for a little bit. I want to talk about them for a little bit, specifically parallel lines. So I want to speak to you about parallel lines for a little bit. Parallel lines. So in these parallel lines, we have something called fun, as we like to call it, in which we can draw up a structure that looks something like this. And then we have another line that goes through both of them, just like that. This is the structure that most people like to talk about when referring to this. So within these parallel lines, we can talk about corresponding angles. Corresponding angles. So we would like here to form a sort of an F shape, denouncing that these are corresponding angles. Corresponding angles look something like this angle and this angle over there. Also this angle and that angle over there. So if we had, here was A and this was A1, let me just try and get rid of everything so that you're able to understand. Let me try and redraw that in a way that you can understand. So if was A and this was A1, this was A2, this was A3, this was A4, and this was B. This was B1, B2, B2, B3, and B4. In order to find corresponding angles, you would have to follow a sort of an S shape, an F shape, just like we denoted here. Fun. So corresponding angles look something like this angle and that angle over there. Those are corresponding angles because this angle forms an F shape with that angle over there. So this leads to them being equal because corresponding angles are equal. So in that case, we'd have to say that angle A1 is equal to angle, this is a B, B1. Then the reason being corresponding angles. So that would be the reason. So now the U in this case, represents co-interior angles, and those angles add up to 180 degrees. So A2 and A4 would add up to 180 degrees because they form a U shape here. So those are co-interior angles. They add up to 180 degrees. And then also we have alternating angles. These are simple things. I'm pretty sure you can be able to know those. And then you also have alternating angles, which are equal. These are angles that form a sort of a Z shape. So which angles would we be referring to? We'd be referring to angle A3 here and angle B2. So angle A3 is equal to angle 2 because of alt alternating angles. So that's your reasoning. They're equal because they form a Z shape. Let me show you the structure here. Can you see it? This angle and that angle. They form a sort of a Z shape here, which if you flip it around, it's sort of like an N that represents the N in the fun, as people like to call it. So that's what I wanted to talk to you about. So in parallel lines, these things they apply, right? That's easy. I'm very sure you could learn that. I'm not trying to delve too deep into that. That's very simple for anybody to learn. So now I want to talk to you guys about circles. So I want to talk to you guys about circles. Circles. So what is a circle? A circle is a structure that looks something like this. Something like that. You'll pardon my drawing. So the circle also has a center, right? And in this circle, we can draw different types of shapes, right? The circle has a particular radius. So this is a line that goes from the center to the circumference. So this is a radius. And we often denounce the radius with the letter R. And the center, they like mostly using the letter O to specify the center. So if you see this kind of a shape, we will be talking about a circle. So this type of shape is a circle. And also, another thing I'd like all of you to know is if you have a line that goes through the center, passes through the center, and then goes to the circumference, this is known as a diameter. This is known as a diameter, which is just double the radius. As you can tell, if a radius is just a line going from the center to here. And also, one thing that you should know is that radiuses are equal throughout the center. So we can draw another radius here. Another radius. This radius is equal to that radius. It's equal to that radius. It's equal to that radius. And also, that means a diameter is equal to 2 times the radius, right? Because a diameter is just 2 radiuses, right? So that's all I wanted to talk to you about for today as we're starting Euclidean geometry. And as I said, I'm trying to ease you into the topic. So if you enjoyed the video, please do consider subscribing and consider hitting the notification bell so that you can get more videos. I'm going to create a playlist for Euclidean geometry, teaching you everything you need to know to ace your exams. So please subscribe and share details of the channels with your friends. Thank you very much. Have a good day.